Welcome to the Not Old Better Show. I'm your host, Paul Vogelsang. As part of our Smithsonian Associates Art of Living series, our guests today on the Not Old Better Show are Piraba, Swaminathan, and Callan Bentley. Swaminathan and Bentley are award-winning science educators, and they're here today to introduce or reintroduce us to the chemical elements that populate the periodic table's elegant columns and rows of 118 elements of matter that really matter.
What really matters? Matter, the stuff that we're made out of, the stuff that everything is made out of, the stuff that everything is, the 118 elements that comprise everything in the universe. This diverse cast of characters shares certain traits in common, certain patterns of size and behavior that organize them into distinct personalities or flavors.
The periodic table of the elements is an elegant tool that helps us make sense of the panoply of elements and to predict the properties of elements not yet discovered. The stories of those elements are insights into the nature of reality, the very atoms that make up our world.
That, of course, are both our guests today, Piraba, Swaminathan, and Callan Bentley, who will be at the Smithsonian Associates Program presenting an evening program, Take an Elemental Journey, a guided tour of the periodic table of elements, Thursday, March 1st, 2018, 6:45 p.m. at the Ripley Center in Washington, D.C. Please join me in welcoming to the Not Old Better Show via Skype, Piraba, Swaminathan, and Callan Bentley. Piraba, Swaminathan, and Callan Bentley, thanks very much for joining the show today.
Thanks for having us.
Thank you.
Yeah, we really appreciate it. I think when we hear the name, the periodic table of elements, many probably don't even realize that chemistry is all around us. We're near the conclusion of the Winter Olympics in South Korea, and whether it's the refrigeration of the ice rink, that uses chemistry. The skis have bases that are reliant on chemistry. The runners of the bobsled, et cetera, et cetera. Chemistry in the modern world is everywhere. What other examples come to your minds?
Well, how about the atoms that make up the athletes themselves? I mean, we are matter, and we top that matter off every time we take a breath, every time we eat a sandwich. We are made out of atoms, and those atoms can just as well be incorporated into something else. So for example, a major constituent of our bodies is the element carbon. And carbon can also be part of the atmosphere. It can be part of a rock. And if we consider where that carbon comes from, I think it's really actually quite profound. Carbon is an atom that's made out of smaller atoms. So in the heart of our sun right now, there are thermonuclear fusion reactions taking place where little tiny hydrogen atoms are being fused together under tremendous temperatures and pressures, and they're fusing to make helium atoms. And those helium atoms get fused together and they make beryllium atoms, and those can get fused together with helium atoms and make carbon atoms. So right now in our sun, carbon is being generated. It's sort of an inferno where carbon's being born. And yet we've got carbon here on Earth, and there's no transport mechanism from the sun to the Earth to deliver atoms. So there's an implication of the carbon atoms that make up our own very bodies as having come from some previous sun, a sun that's long dead, a sun that's blown itself to smithereens. And our solar system is made of the remains of that discarded solar system of bygone times.
Thank you very much. Piraba, this is all fascinating to me, but how do we make this even more interesting to the average person? Why should the average person care about the periodic table of elements?
So generally, when you're looking at the periodic table has vast amount of information in it. It's really a piece of art and science combined together. when you take a look at the periodic table, it's made up of these elements, which is comprised of these atoms. So you can either go really in deeper and deeper and deeper into the atom and look at the behavior of the protons and neutrons within the nucleus, or the behavior of the electrons that surround the nucleus. The position that these elements take up on the periodic table is in itself a cleverly put together piece of art. For example, the elements are arranged in such a way that they have similar properties. These amazing scientists throughout our history have come together to form this amazing piece of art. And as you see from the periodic table, the elements of particular categories behave in a similar manner. So you can predict how a particular atom would behave with another member of the periodic table. So you can either go inwards within the periodic table and look at the elements and the details of the atoms within that element, or you can go outwards and build a bigger and bigger and bigger picture of how these elements interact with each other within our body, within the universe, with everything around us. So as a person who is just looking at the periodic table, it could just be letters and numbers, but there's so much information within it that is so intriguing. The more questions we ask, the more and more we want to learn.
Piraba, as a follow-up to you then, the periodic table of elements does have some elegance, certainly, as you look at it. The organization of the table is interesting. The lightest elements are on top, the heaviest are lower. Why is that? Is that just weight?
Initially, when Dmitry Mendeleev and few other scientists noticed the trend in terms of the mass within the nucleus, yes, as the mass was increasing, they arranged the elements in the order of that size. But the current periodic table is built in the order of the number of protons that make up that particular atom or the element. So hydrogen, being the smallest, has 1 proton, and then the newest member, one of the newest members, which was added to the periodic table in 2016, is oganesson, which is 118 protons. And it's still building. It is still being built. There are locations in the periodic table which are placeholders, which we can predict the properties of the element that will need to be discovered. So as a result, scientists know what they're looking for, or the properties that they're looking for. However, it hasn't been discovered yet.
So Callan, Bentley, we're still finding new elements.
Sure, yeah, we are. There are scientists who make it their life's work to smash together large weight atoms and hope that for a few microseconds they will stick together and make a larger composite atom. And if they're able to demonstrate that, they have added a new type of matter to the periodic table, and it's a big honor. One of the atoms that you'll find, or one of the elements that you will find at the end of the periodic table, is one called seaborgium, which is named for Glenn Seaborg, who discovered or helped to discover 10 of the elements on the periodic table. Now remember, there's only just over 100, so almost 10% of the periodic table of the elements that we know about in the universe, we know about thanks to his work. And so he, of course, is honored by having one of those elements named after him. He's the only person who has had that honor while he was still alive, but it's been applied posthumously to Albert Einstein and Marie Curie and a host of others.
And there are common properties that are looked for, that are sought after, really, in finding some of these elements, right? And what are some of the common properties?
Well, it depends on where you're looking. So in the periodic table as it exists now, the far right side is what we call the noble gases. And these gases are considered noble because they don't react. They don't like to play with other atoms, and as a result, they are sort of seen as exemplary in some sort of Platonic sense, I guess. So that's why they're considered noble. So if you were looking for another element that would fit in that last column, but underneath all the other ones there, you would expect it to have those same similar properties. But if it's going to be one column to the left of that or one to the right, which basically puts it down on the next row, then it's going to be highly reactive and eager to make ionic bonds so that it can, as a bonded compound, act more like one of those noble gases.
So, Piraba, then final question for you. Neon, is that one of the noble gases? And would we find that maybe around the house or in the garage, someplace close by?
Neon is, again, a noble gas, which is quite stable, and the electrons work in a very interesting manner. The neon lights that you see around on festival days would be because of those electrons moving from one space to the other and emitting those lights, which is what we get to see as bright, different colored lights.
Good. Well, Piraba, Swaminathan, thank you very much. Callan, Bentley, thank you very much for joining us today. I will point out that this is such fascinating stuff. This particular program is sold out. So check back with our website, check at the Smithsonian Associates, and we'll post updates and where you can find out additional information. But thank you both for joining us today.
Sure thing. It was a pleasure. Thanks for having us.
Thank you for having us.
Thanks, guys. My thanks to our guests today, Piraba Swaminathan and Callan Bentley, who will be presenting at the Smithsonian Associates Program Thursday, March 1st, 2018. The program is sold out, so please check the website or call 202-633-3030 for more information about getting on the wait list. My thanks as well to the Smithsonian team for all they do to support our interviews. As usual, we'll post links to everything. And also, as usual, my thanks to you, the listeners, for joining me today. Your time is valuable, and I'm grateful you're spending some of it with me. I'm always interested in feedback, and you can leave that at iTunes, Google Play, or send me email at info@notold-better.com. Stay tuned for our next show, another great one as we talk about better. The Not Old Better Show. Thanks, everybody.